So earlier on, we were talking about this extraction of iron. So you have the blast furnace. So the summary is that the blast furnace is something very big. Then what you do is you have raw materials like this tree that will be placed from the top into the blast furnace, and you pump in hot air, which is supplying oxygen into the blast furnace. Then a few processes, a few chemical reaction happens. So such as the coke reacts with the oxygen and form carbon dioxide and also carbon monoxide. Then the carbon monoxide and carbon dioxide reacts with the iron ore. Then you will get iron. So iron will sink downward. Then the limestone here will react with the impurities inside here. So then a certain reaction happens and it forms molten slag and it sinks downwards. Then yeah, it's something like that. Then from the image, right, you see that temperature is very high, ranging from 1005 to close to 2000 degrees. And the whole process, the chemical reactions will produce some other gas and it will be expelled as waste gas. So we will come back to the waste gas later in a while. Then, so we say chemical reaction takes place. I don't think I went through the chemical reactions in detail. Now I'm going through the reactions in detail. You have the setup, then the identities of this tree you must know. So when all these tree drops in, right, the carbon will react with the oxygen from here. So the oxygen goes in and the carbon is here. So the carbon will react with the oxygen to give you carbon dioxide. Then it is an exothermic reaction. Do I have to explain the term exothermic? Yeah. Exothermic means it is a reaction that releases energy. So carbon and oxygen is like you can think about it as you burn a candle, then you sit down there. So you burn a candle and you sit next to the candle, you will feel the heat coming to you, right? So the carbon plus oxygen reaction is the feeling, right, is very somewhat similar to candle burning. Then you sit next to it, then you feel the heat coming to you, or you sit next to a fireplace and then heat coming to you. That is something like that. Okay, that is an exothermic reaction. Okay, all right. Yeah. So there's a stage one. Stage one happens. Then you have stage two. Just now you see it. Just now you see carbon dioxide being released here. So now inside here there is carbon dioxide. So inside there is carbon dioxide. Okay. So you have more carbon coming in. Carbon will react with that carbon dioxide. Then you form carbon monoxide. Okay, so that's stage two. Then subsequently, the carbon monoxide that is in here reacts with this that also is inside. So these two will react. So what happened is, right, the iron oxide becomes iron. Then the carbon monoxide becomes carbon dioxide. So in this case, right, there is a special name for carbon monoxide. You call it the reducing agent. For now, right, you don't have to know what is a reducing agent. You just need to know that carbon monoxide is a reducing agent. Okay? You just need to know carbon monoxide equals to reducing agent. That's all. You don't need to know the intricate details of what is a reducing agent and what is an oxidizing agent. That one don't need to know now. Because for you that I think oxidation and reduction is taught in Sec 5. So you don't have to know that at the moment. So you have the iron. So physically iron is dense metal and there is high temperature here. So that means iron that is formed will be in liquid form because the temperature is too high. So this liquid dense metal will sink down and then you'll be found at the bottom of the blast furnace. It flows down because it's a liquid and then it is right at the bottom because it's very dense. So very heavy. Okay. So far what gases are released? You have carbon monoxide, carbon dioxide is released, right? Yeah. Then we use oxygen, then hot air, yeah. Hot air, what is in hot air other than oxygen? What are the components of air? Primary school science. Can you tell me what is in air? Yeah. That hot air or air itself is made up of oxygen, nitrogen, and some other gases. So you have a lot of nitrogen in here. Yeah, the question is there for a reason. You just continue. Okay, so then we have our metals already. Then we need to remove impurities. So we have this calcium carbonate. Calcium carbonate, because, okay, down here, right, is high temperature. So the whole setup is high temperature. Now calcium carbonate, right, plus heat, right, it will decompose. What is decompose? What does decompose
It
mean?
will break down.
Yes. So they tell you that calcium carbonate will break down into carbon dioxide and calcium oxide. Okay. Revision time. What kind of oxide is calcium oxide? Is it an acidic oxide, a neutral oxide, a basic oxide, or an amphoteric oxide?
Acidic oxide.
Why is calcium carbonate acidic oxide? So there are four types of oxide: basic oxide, amphoteric oxide. Okay, revision. Then acidic oxide
Acidic neutral.
and neutral. Okay, so let's revise, huh? So these two are metal oxides. These two are non-metal oxides. So, so you know your answer is not correct already.
It's a basic oxide.
Okay, so basic oxide means it's a metal oxide. Metal oxide that reacts with acid. It has alkaline properties. Amphoteric oxide is a metal oxide that has both acidic and alkaline properties. So that means it reacts with acid, it reacts with bases. Acidic oxide means it is a non-metal oxide that has acid. It behaves like acid. So it reacts with, it is acidic, so it reacts with metal oxides or metals. I think then neutral oxide is it doesn't react with anything, right? So then just now you say calcium oxide is a basic oxide. Okay, you said that, right? So when you change your
Okay.
answer. Okay, so then it forms that decomposition forms basic oxide, calcium oxide. So the step two, there is this formation of slag. So what happened is that it reacts with impurities. Here you say impurities. Impurities in this reaction, this blast furnace, right? They are talking about sand. And the chemical formula for sand is SiO2. Okay, so now they say calcium oxide will react with sand. So by looking at the chemical formula of sand, can you tell me what kind of oxide silicon dioxide is? What kind of oxide is this? Likely to be. What kind of oxide is it likely to be? Based on acidic. Okay. So your acidic oxide will, so this line tells you that acidic oxide will react with basic oxide, then you form another third substance. So slag has this formula, and slag is also called calcium silicate. So what you use for slag is you build roads, make cement. Okay.
Yeah.
So these equations are very important. They make you reproduce it, they make you write it, they make you explain the process. So you need to know the equations. Oh yeah, by the way, just now I said I have to come back to the waste gases, right? So if you look at this part, you get carbon dioxide, carbon monoxide, and oxygen. Oxygen is the useful one. Then there's another gas, nitrogen. Nitrogen that is in air, right? But there's no use. You don't see nitrogen dioxide being used at all. Not nitrogen. No, sorry, you don't see nitrogen gas being used at all. So what happened is, right, those that are not used, right, or the excess gas, right, that are released, the excess gas will be released to the surroundings. So these are released as waste gas. So the waste gases are these few gases. Okay, because this question, what is in waste gas, is a legit exam question. I think some MCQ question. So I have to talk about it. Okay, now this one. Hematite, coke, and carbon. These two are the same. Coke and carbon is the same thing.
Limestone.
Yeah, limestone. Okay, next one. Name and write the chemical formula of the main iron ore. Iron 3 oxide. Next one. Name the substance entering the blast furnace at B. What is in hot air?
Oxygen and nitrogen.
So this one is a continuation of this question. So you have hot air. Name the substance entering the blast furnace at B. You say hot air. So this question is, why is hot air important? It's a source of oxygen. Why is oxygen important?
To form the molten slag.
Oxygen doesn't form molten slag, right? That's
Form the carbon dioxide.
Yeah, the oxygen is here to form carbon dioxide, so that carbon dioxide will produce carbon monoxide. Okay, this one, write the 3 stages, the chemical reaction, describe the thing. Say the stage 1 is formation of carbon dioxide, so write the equation for it. So you have to be careful of the state symbols. If they ask you for state symbol, then you have to write it. This one, second one. Is it balanced? Is it balanced? Yeah, answer. This one answer is. I think I didn't type properly. Carbon, carbon. So two. Then two oxygen here. Correct. Okay. I mistyped. Extraction of iron. Iron oxide plus carbon dioxide is So two iron, three carbon, three oxygen, six oxygen, Yeah. Next one. C is molten slag. Okay. Next one. Describe how this substance is formed and drained out from the blast furnace. So it's the formation of slag. If you can't describe, at least write out the chemical equation. Calcium carbonate decomposes to calcium oxide. Calcium oxide reacts with silicon dioxide sand, the slag, to form slag. The slag floats. Okay. Okay. Write the chemical equation. Calcium oxide. Okay. All right. Two applications of this substance: building roads and make cement, road construction. Name the substance which flows out from the blast furnace at D. Molten iron. Okay. Name 3 components in waste gas. Sounds familiar. Nitrogen, carbon dioxide, carbon monoxide. Yep.